Yeah, thank you so much. So I skipped the introduction, I guess. Um, so there is there is the other talk that I wanted to give is why microservices fail. And I'm talking about some common patterns. I had to cut back a few of them, so there is a more extensive list, but here are just a few. So one of them is the common data model. So here's our data model, and the citation from that project would be, we have to have some common data, right? So obviously we have to have a common data model. That model actually comes in a lot of different fashions. So we have an order process, we have a delivery process, and we have invoicing. And obviously all of these need to have, you know, the customer, the item that is ordered, these kinds of things. So obviously there is shared data, isn't there? And we use that for communication only because, well, we learned that every microservice should have a separate database with a separate data model, but we do use the same model for communication because, well, obviously there is the item in the enterprise, so there should be a common data model there. And in that particular system, they actually made that a common library because you don't want to write those classes, those objects again and again in every system. And the result, and of course every service needs to use the latest version of the library because if you have a change it needs to be propagated to all the services. And what you end up with is that a change leads to a redeployment of all services because you do an update of the library, every system has to use the latest version of the library, so you have to redeploy all the services, and there you go. So there is no decoupled deployment anymore, and I would argue that you just build a deployment monolith because you can just deploy the system as a whole. And by definition, I would argue that's a deployment monolith, but you did it in a way that there are the technologies in place, like Docker containers and so on. So you actually get all the additional overhead of the operations side. This is somewhat obvious. I would argue that this is also something that comes in other fashions. So for example, there are events. So this time around, we send the events and we say, here is a new order or a new item or what have you. And we store that in Kafka. And the nice thing about Kafka is that Kafka can store events pretty much forever. And you can basically, well, now you can build your local state from the events, right? So there are all the events in the Kafka queue, so I can just get rid of my local state and I can just reprocess all of the events and I'm back again. I would argue that this is actually not such a brilliant idea, in particular if you have a common data model that has the model of the event, because it means that everyone is using this model, as you can see in this, well, small graph, right? Each of those services is using the same model, so it's hard to change the model because there are so many dependencies. If I do a change, I would probably need to talk to everyone. And in particular, if I remove something, so who's using that attribute? I don't know. Shall we remove it? No, too risky. And if that's your situation, you just signed up for a model that will just keep growing and growing and growing. And the other thing here is, in particular, if you rely on the events to rebuild your local state, it basically means that in a way you just introduced a global storage for the state of the system, something that we wanted to get rid of, right? We want to have separate databases, we want to have separate persistency. This is shared persistency. It's just that it comes in the form of events. It's just something that we call different. It's not that much different from a centralized database. So what's the cure? So how shall we get around that? I would argue that we should use separate local data models, which is sort of easy and well understood. So I would argue that you should at least consider specific data models for each interface between two separate microservices. And in this particular case, I would argue that there should probably be a specific data model between delivery and the order, and another one between invoicing and the order. And actually, if you think about it, there are not too many redundancies, because invoicing is well, talking about prices and taxation and all these kinds of things, while delivery is concerned about how much the items weigh, how you can get them to the customer. So the information from the order that you need to transfer to delivery and invoicing is actually probably, there is not too much overlap, so there is not too much redundancy. So I would argue this is actually the better model concerning the functionality. Now you could argue, well, we are going to have a ton of data models, and I would say, well, yeah, that's true, but there are two goals here, and you need to consider which goal is more important to you, either independence or just one model. So it's a trade-off between the independence or just having one model. It's a trade-off. It's what we do in software architecture. And I would argue there is no one single best solution. In the example that I just presented, I would argue there is a single best solution, which is not a shared data model to separate, because that's closer, in my opinion, to what really happens in the domain. But you might come up with other cases where this is not the case. Okay, what else is there? I would argue that synchronous calls are a problem. And that is actually very attractive, because that's how Netflix did it. So that's what Stefan said this morning. And actually, in a way, what he said is it's perfectly fine to do it because of scalability reasons. I have to admit that I have a slightly different position, I guess. So first of all, what's the problem? Well, we have some call coming in from the outside, so we call another microservice, which calls another microservice, and that microservice calls that one, and so on and so on. So we get some kind of call graph. And this is actually something that you can easily see in systems where you have tracing support, that these kinds of call graphs actually do exist. And the nice thing about this is that it's very easy to understand. So if you are used to object-oriented or imperative programming, you know how this works. It's just a call graph, right? It's something that you're used to. It's very similar to local programs. And I would argue that this is the reason why we see this, because it's very easy to understand. That's the reason. It's not about, I don't really believe that this is around better scalability. I think that's the reason, better to understand. What are the challenges? Well, first of all, the latencies add up. So I have a call graph of depth 2, and I have 2 or 3 services that are called. So all of these latencies add up until I send a response back. You can deal with that by using some parallel processing, but still you have a lot of network round trips, and there is the first law of distributed objects, which says don't distribute your objects, so you're violating that too. If you have a service that has all the data about, let's say, items, and that service is down, how do I compensate that failure? I don't have data available for items, so what shall I do now? I don't know. So in some cases, it's hard to compensate failures, which leads to, well, flaky services that just fail. And asynchronous communication has a benefit here because it has resilience sort of built in. If one of the services fails, the message is just transferred later. And there are network issues due to the network traffic. So I would rather go for the obvious cure, which is asynchronous processing. And of course, you can make the whole thing worse. So if you build an entity service, so you say, here are my 3 microservices, and here's our customer service, and here's our item service, then you get a lot of problems, because first of all, that might easily become a centralized data model, which we previously said is an issue. And also, that is probably something that you can only do if you do synchronous calls. Because if you do an order, you probably need to have the information about the item that was ordered to process the order. So you probably need to do a synchronous call here. So you get those problems. And also, well, each call goes through 3 services in my example. So there is a performance problem, there is a latency problem, and you get all the problems that we spoke about. And if one of the systems fails, well, probably the other systems will fail too, so you end up with flaky services. And in a way, that's very similar to, if you look at it from, I don't know, 10,000 feet perspective, it's probably very similar to having a common database down here. So we just had the entity services, so now we are having a common database. Might again lead to a centralized data model. You probably don't have any performance or latency issues because you need to store the data in some database anyway. And it shouldn't be flaky, so if you have a centralized database and you take care of the fact that you shouldn't have a common data model, you should probably be fine. The cure is that every microservice should have its own data model. It's actually what domain-driven design said. It says there is a bounded context, there is a separate data model, and that is what we have been seeing there. So you might share a database, but you would use separate schemas because the data models should be separate. If you have a shared database, depending on how available that database is, you might end up with flaky services, but usually the databases are not that much of a problem, so I would argue that's not a big deal. So that's around, you know, data model and entity services and these kinds of things. And it's weird because entity service, for example, is really a name of a pattern. So I would argue that it's rather an anti-pattern. What else is there? I see a very weird thing sometimes. Well, bad structures is not that weird, but it's just the name of an anti-pattern, I would argue. So the idea is, as soon as you use microservices, all of this magic happens, right? It's a flexible system, it's maintainable, and there you go. So here's a graph of a badly structured monolith. This is what it looks like, and here is a bad structure of a microservices system. It's the same thing, right? And it's very important to point out that a microservice is just another type of module. That's what it is. So if you messed up your structure, it's not going to be better if you use microservices. That's not what's going to happen. It's actually the opposite. I would argue if you have a badly structured microservices system, you have a lot of problems because you have the additional overhead of microservices. You have the problem that, you know, in a deployment monolith, you could at least hit that big button and deploy it, while if you have a microservices system, you would need to hit multiple buttons and coordinate the deployment, so it's actually worse, and so on and so on. So I would argue, if you want to fix the structure, microservices won't help you. That is not the idea. It's just a different type of module. So if you want to fix the structure, fix the structure. There you go. And as I said, I think that's really one of the problems because people don't, in my opinion, domain-driven design and the ideas around how you separate your system into modules, it's much more important than doing microservices. And I'm actually grateful for the discussion around domain-driven design that we have now, because I think that originates from the microservices hype and the renaissance of domain-driven design because of that. Then there is the organization. So there are people, and the idea is, so that's sort of a quote from a team, an imaginary team that could suffer from that problem. So the architects will decide, because the teams are too dumb to do that, so they are not up to the challenge. And as I said, microservices enable independent teams, so they enable independent technologies. If you have independent technologies, the nice thing about that is that I can decide that I want to do that Java update now, and the other teams don't do it. And I don't need to coordinate with them, I just do it myself. Because my microservice, my decision which Java version I'm using, so I just go ahead and do it. Also, there should be independent parts of the domain. So there is a bounded context. Ideally, I should have a stream of stories coming into my team. I implement them, and that's it. And it's my decision how I do it. If I have a centralized decision, it basically means that I don't have independent teams because there is someone else making those decisions. So that reduces the benefit of microservices. And as I said, I think there is a problem here because it's not really around the architecture, it's around a different type of organization, and that's probably the much harder thing to do. And how do you solve that? I would argue, I actually like that metaphor of a leap of faith. It's about faith in your teams and in your people, and then you take the leap. So you do empower the teams to make those decisions because you, at the end of the day, trust them. And the key thing here is if you actually do trust people, they behave differently. Because, well, they know that they are responsible and the stuff that they are doing is the stuff that gets into production. And if you have the developers, if you tell the developers what you are doing is going straight into production, there is no QA team, they will probably behave differently because there's no one else catching their errors. So probably they will come up with a better approach to software development, and probably that will be a thing. So what I'm trying to say here is, and I really urge you to research the story about the NUMA plant. The NUMA plant is a plant that Toyota did together with General Motors. Before that joint venture, when General Motors was doing that plant by themselves, it was a nightmare with drug addicts on the line and, you know, drunken people, all these kinds of things. Then they did the collaboration between Toyota and GM. They fired all of the people, obviously, because, you know, you can trust them. So they had no one to run the plant. So they hired 80% of the same people. And that plant became the most productive plant that GM had. So if you trust people, there is, you know, they behave differently. So, and I think that's a very important story to take home here. So the conclusion, I would argue concerning microservices, the problem is not really microservices, it's about trade-offs. And I rather like to have a conversation where someone tells me, well, this is our architecture, and I'm like, yeah, that's not what I wrote in my book. But that person tells me, well, we have good reasons for not doing that because we thought about that, and this is how we are doing, and this is what we ended up with. I would still argue that there is, I would still argue that what I presented here are really challenges, and if you would need to have very good reasons to violate them. If you do it the way that I presented it, you're probably going to get a failure, and I would rather not do that. So even though there is no black and white in software architecture, I actually believe that these are real challenges. There is a paper for if you want to see more challenges. There is a longer presentation if you want to look at the slides. I want to conclude by giving you a few generally useful links probably. So if you're looking for some small microservices examples, here are 11 demos that you can try and, you know, distribute to your students or use for your own stuff. It's all Apache license, so do whatever you are happy with. There is one about service meshes, Kubernetes, all kinds of stuff. If you found that useful, here's an email address. You get the slides plus all of my free booklets and samples from my books. This is, by the way, powered by Amazon Lambda, so your email address is will be written down in a log file on the Amazon cloud for 14 days and then deleted. So it's actually a microservice that you're talking to and not myself. Yeah, and that's pretty much it. Thanks. I hope you enjoyed the talk.
Thank you, Eberhard, for this interesting talks. Are there any questions on this talk? Okay.
Do you think some approaches like GraphQL or the presented wish list from Olaf will solve the centralized data model issue?
I would argue that GraphQL, I mean, if you think about it, it's basically a SQL for REST. So what you're saying is you're exposing your data model. That's it. And I don't see, that's actually the absence of domain logic. What you're saying is, here's my data, use it. And I think that's not just bad from an architectural standpoint concerning information hiding. I think it also means that you didn't really understand the domain in a way. And if you look at it, if you look at domain-driven design, there is the repository pattern, and the repository pattern actually says encapsulate the access to the persistent storage and provide meaningful access methods to it. So it's something that we have been discussing for 15 years, and I don't see why you would use that approach and that technology. I mean, SQL, of course, has some, there are some areas where you would use SQL. There are probably some areas where you would use GraphQL, but it's not useful if you have meaningful business logic in your microservices.
Okay, thanks. Are there other questions? Yeah.
I'm not a great fan of GraphQL myself, but I have to disagree very strongly with the statement you've just made. Because nobody says that the data the GraphQL engine operates upon is the persistent data stored down there in the DDD repository or in the SQL database, let alone the data that the business logic that's organized according to DDD is working with. We're in the presentation or in the interface layer, integrating systems, and that's where it can play its role because it brings flexibility. Right? And earlier on you made the point about pros and cons and trade-offs, which is a good message, and kind of seems to conflict with this strong anti-GraphQL statement you just made.
Yeah, I mean, the reason why I did that is because I think it makes sense to, to clearly say, make a statement. And I have to admit that in this specific case, I would be pretty hard to convince. If there are other approaches, obviously. There are other approaches that are working. And for example, I presented the Netflix approach that is obviously working, that I would still not recommend to any of my customers. And this is a very similar case where I would argue, okay, I do see that there is a technology, I do see the value, but I would just not introduce it in a project that I do. I would argue that the basic concept that I suggest is to split apart your domain into bounded context, which means that you want to split apart your domain models, such as item, custom, and so on. Parts of those domain objects like customer, a specific part would go to delivery, another part would go to invoicing, so the information how I pay stuff would go to invoicing, the information about how I want to get stuff delivered would go to delivery. And I don't see why any other bounded context would be interested in that kind of information. I would argue that this is violating encapsulation. At the end of the day, it's about functionalities such as delivery and invoicing that those microservices should provide. And the data is just hidden inside, which is encapsulation, basically.
Take the scenario that the exact same business logic is used in a smartphone application and in a rich client application. Sam Newman has a pattern called backend for frontend for that, and it just deals with the representation of the data that goes back and forth. It has nothing to do with the domain separation or the decomposition of the domain layer into subdomains, which is the exact pattern in domain-driven design for that. It's a different layer we're talking about.
Yeah, I'm arguing for systems that don't really have layers spread across microservices. So one microservice would include all layers, including presentation, logic, and persistence. And that is basically what a bounded context is about. And I'm totally fine with a rich client or a mobile app using the very same domain logic exposed via an interface such as REST or of this kind. what I see in customers a lot of times is a huge centralized database that is very complex and nobody knows what is going on there, and it's basically not maintainable and changeable anymore. That is the reason why I would argue that you should encapsulate your data, you should not expose it, and in particular you should split it apart, because these large databases, I don't see how to tackle them otherwise except for splitting it apart and making it smaller.
Okay, no, it's a very interesting debate, but unfortunately the time is finished. Thank you again
Yep,
for
thanks a
your
lot.
presentations.